You've seen this before. Cream poured into coffee, ink dropped into a glass of water, smoke from a candle curling upward, and then suddenly, not. Something shifts, it unfolds, it becomes something alive. That's fluid dynamics, and it happens everywhere, all the time, in the weather, in your bloodstream, in the air bending around an airplane wing, in the ocean, in the inside of a star. For most of history, we watched it and wondered. Then, in the 1800s, two mathematicians, Navier and Stokes, wrote it down. They described how fluids move, how pressure pushes, how momentum carries, how one layer drags against another. A handful of equations, elegant, compact, powerful. Those equations work. We use them every day to predict hurricanes, design engines, simulate blood flow through artificial hearts. Here's the strange part. We still don't fully understand them. There's a $1 million prize, one of the hardest open problems in mathematics, for anyone who can prove that the equations always behave, that they never break. Because in theory, under the right conditions, a smooth, calm fluid could develop a point of infinite velocity, a singularity. The math just explodes. No one has ever seen this happen in real life, but no one has proven it can't. What you're watching is a simulation of that mystery. Fluids starting calm, then disturbed, swirling into eddies, eddies folding into smaller eddies, passing energy down and down until it finally dissolves into warmth. We can see it, we can simulate it, we can feel it. We just can't completely explain it. I'm Gladys. If flow stayed with you, a like and subscribe helps more than you know. I'll see you in the next one.